Here we go with what I assume is going to be our last video for Chapter 2. And we're going to be talking about our last category of acids, which are called Oxo Acids. But basically they're just acids made up of polyatomic ions. So what you want to look for are those leading hydrogens. Again, so look for the leading hydrogen. But in this case, not binary. All right? In this case, you will have more than two elements in the compound. Remember, binary compounds, two elements only. Oxo acids, or acids of polyatomics, will have more than two elements in that compound, so it won't follow the same binary rules. Now, the trick with oxo acids is if your polyatomic ends in an ATE, when you make an acid out of it, ATE becomes ic acid. Okay, so you say the name of the polyatomic, and you say if it's an ATE, it becomes ic acid. So if I have, for example, sulfate, right, that's got the ATE version, SO4 2-. If I make it an acid by making it H2SO4, right, notice that leading hydrogen, doesn't matter that there's two of them, I just need two hydrogens to balance the 2- charge. So I see that polyatomic as sulfate, and I see that hydrogen in front, that means that it's an acid. So that 8 becomes ic acid. So I say the base of the polyatomic. So I'm going to say sulfuric acid. Right, there's my base, and then I have my ic acid. Right, so if I have, let's say, HClO3, right, notice that's chlorate, and then I have that leading hydrogen that tells me that it's going to be an acid. So 8 becomes ic, so chlorate becomes chloric acid. Right, there's my ic acid for an ATE. Now, if we have something that is an ite, ites become us acid. Right, so let's take a look at chlorite. Right, so if I have HClO2, we recognize that ClO2 is chlorite, and we have that leading hydrogen that tells us we are an acid. So chlorite becomes chlorus. Oops. Acid. So if I have H3PO3, right, that is, PO3 is phosphite. And I see that I've got a leading hydrogen. I have 3 of them because phosphite is a 3- polyatomic. So I need 3 hydrogens to balance that 3-. The number of hydrogens doesn't matter, okay? So phosphite becomes an OUS. So that becomes, it's a little bit different, but phosphorus. Phosphorus acid. Okay, that phosphor is still the base of phosphite. So sulfuric and sulfurous, phosphorus acid, but ites still become us's. And coming back up here, 8's become ics. Let's take a look at another one that's a little different. So if I have HClO, which happens to be a main ingredient in bleach. Okay, ClO, that's hypochlorite. We have a leading hydrogen that tells us it's an acid. So just because the hypo is there doesn't change the strategy. This becomes hypochlorous acid. Okay, so if I had perchlorate and I made an acid out of it, it would become perchloric. Okay? So our last topic, well, our next to last topic, is a completely different category called hydrates. Hydrates. Okay? And so we say the name of the compound, and then we use a prefix and the word hydrate. All right, so let me just write that out, and then we'll show an example. So the normal name of the compound plus a prefix plus hydrate. Okay, now the hydrate, the prefix part tells us how many hydrates there are. Okay, so if I have a compound that looks like this, I'll have COCl2, and we'll see a dot, like a multiplication dot, 6H2O. Okay, so first we name the compound. Right, now cobalt is one of those ones that makes multiple ions. I have 2 chlorines there. Each one of those is a 1-, so that means that this one has to be a 2+. So I'm going to name that part of the compound just like normal. So I'll have cobalt 2 chloride. Now the prefix for 6 is hexa. And then the word hydrate. So cobalt, there should be an E on the end of chloride. Cobalt 2 chloride hexahydrate. Right? Hydrate is the description for the H2O. Hexa tells us there are 6 of them. Okay, remember your prefixes from way back naming covalent compounds? Mono, di, tri, tetra, penta, hexa. That's where we get the hexa from. All right, let's do another one. Let's start with the name and come up with the formula. So if I have the name as copper 2 sulfate pentahydrate. Okay, so the copper 2 sulfate, I come up with the formula just like normal. So sulfate is SO4 2-, and it's a 2-. And if I have copper 2, that means that it's copper 2+. So 2+ balances a 2-. So we just have CuSO4, and we leave off the 2- part. Then we put a dot, like a multiplication symbol, and it's pentahydrate. So penta is the prefix for 5. So I'll say 5H2O. Now, just as fair warning, we've been through a whole bunch of naming, a whole bunch of nomenclature so far. You need to be able to go from formula to name and name to formula, both directions. All right, so now, finally getting into our last topic. and that is naming simple organic compounds. Okay, and so we're talking about chains of carbons. Okay, so carbon chains, that's what organic chemistry is all about. And the naming of simple organics is based on the number of carbons in the chain. Number of carbons in the chain. Right, and we use the prefixes, right, but they're a little bit different at the beginning. So the number of carbons, so if I have 1, the prefix for 1 carbon is meth, 2 is eth, 3 is prop, 4 is bute. And the rest are comfortable and common. Okay, so 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. Okay, so the only weird ones are the first ones. That's meth, eth, prop, and bute. Okay, and I wish I could offer a good mnemonic or something, but I just learned it by saying that over and over and over. Meth, eth, prop, bute. And I still say it inside my head every time I have to do one of those. So the prefix tells us how many carbons, okay, and then the suffix tells us what type of bonds. Okay, so if I have single bonds, we have the suffix of ane, A-N-E. If I have double bonds, I have E-N-E, een. And if I have triple bonds, it's yne, Y-N-E. Okay, so let's do a little bit of practice. All right, so if I have a molecule that looks like this, okay, it's a single carbon. There's only 1 carbon in the chain. 1 carbon. So the prefix for 1 carbon is meth. It can't be anything but singly bonded. So I say methane. Okay, so methane. Same thing that comes out of cows. If I have 2 carbons, right? The prefix is based on the number of carbons in the chain. So 2 carbons in the chain. So I have eth is my prefix, singly bonded, so ethane. Now if I had something that looks like this one, I still have 2 carbons, but they're double bonded, right? So I'll still use that eth prefix, but the double bond gives me a suffix of ene, so ethene. Okay, sometimes that's referred to as ethylene, ethylene. Okay, so count the number of carbons, determine what kind of bonding you have, prefix and suffix. Now, if we have something attached, okay, let's talk about alcohols real quick. Right, so we have, with an alcohol, we have a carbon chain with an OH attached, a hydroxide group. Right? The rules are the same for naming, but we end with an OL at the end. We use all. Right, so for example, if I have C, 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 OH, and hopefully you're recognizing that OH is one of your polyatomics called a hydroxide. Right, so we would say that we have 3 carbons in the chain, so that I get a prefix of prop. We're singly bonded, so we get the ane, and then it's an alcohol, got that OH group on there, so I get an all. Right, so when I put those all together, I get prop and all. Right, so those are the 3 parts, the prop, the ane, and the all. Put them all together and you get propanol. And that is going to do it for chapter 3. We've had a lot of videos for this chapter, and I hope that you're as happy as I am to be done making videos for this chapter. We will come back with chapter 3 as soon as I can get to it.